In this section, I'm going through S1 section 4.7 and its probability formulae. Now, the two formulas that we are looking at, we have actually been using in calculations using the Venn diagrams, the sample space, the two-way tables, without even realizing that there is a formula to it. So this section is about formalizing what we have been doing and giving you a couple of formulas. Formula 1 is the addition formula, and it links in, well, it says how do I find the union between A and B. So if two events are linked, if they have an intersection, if I know the probability of A and the probability of B, and if I know what the intersection is, I start in the Venn diagram by putting the intersection first. And then if I know the probability of A as a whole, I do A minus the intersection, and I find just this section. And then I do B minus the intersection. And so the union of A and B is A minus I plus B minus I. All of these together give you A and B minus I minus the intersection. So to find the union of A and B, and we're talking about potentially independent events, well, certainly not mutually exclusive events, because mutually exclusive events would not have that. So it's the union is going to be the probability of A plus the probability of B minus the intersection of A and B. And of course you can rearrange any formula, you can rearrange it. So the intersection of A and B, it's a minus, so if I move it that way, it becomes a plus, and it becomes the probability of A plus the probability of B minus the probability of the union of A and B, because I'm moving that there. So you can rearrange these as well. So for here it says A and B are two events with probability of A 0.6 and probability of B is 0.7. The union of A and B is 0.9. Find the intersection of A and B. Now, because they have not said that the that the A and B are independent events, you can't just, what's a bad color? You can't just multiply them together. So what I can do is rearrange instead, and my rearrangement says that the probability of the intersection is the probability of A plus the probability of B minus the union. And that is going to be 0.4. So unless they specifically say that these are independent events and you can multiply A and B to find the intersection, if they've given you the union, you can use the addition formula, rearrange that. Now, formula 2 is really a formula for the probability of B. I want to find B given A. Well, remember, and I'm going to use the example from section 4.6 here. This is an example that we did. We put, and for example, for something, that was a question we had to solve. Find the probability of the complement of A given the complement of B. Once we are given something, that restricts our sample space. That means I am only considering things in the complement of B. I'm not considering anything else. So the complement of B is this space. So everything that I've shaded becomes my denominator. So my denominator is the complement of B. And I want to find the complement of A, but it's not simply the complement of A, it's actually the intersection, what the complement of B and the complement of A have in common. So I'm finding the intersection between my denominator, my total, and what it is I'm looking for. And we ended up saying that actually this became 0.2 over 0.6, and it was a third. And that's what they're basically saying. I mean, we use this formula without even realizing that we were using this formula in the section above. The probability of B given A is the probability of the intersection between B and A divided by the probability of A. And of course, if it's the other way around, if it's the probability of A given B, it's the probability of the intersection of A and B divided by the probability of what we are given. So what we are given always is the denominator. And that's what this formula is about. So let's have a look. C and D are two events such that the probability of C is 0.2, the probability of D is 0.6, the probability of C given D is 0.3. Find the probability of the intersection between C and D. Okay, so I'm going to start here. The probability of C given D is the probability of the intersection between C and D divided by the probability of D. And this is something that I can rearrange because I am trying to find this. So I'm trying to make this the subject. So I'm going to multiply up. So the probability I want is going to be 0.3 times, which is probability of C given D, times the probability of D, which is 0.18. So the probability of the intersection is 0.18. Find the probability of D given C. Okay, so that's going to be the probability of the intersection between D and C divided by the probability of C. Well, the intersection of C and D is the same as D and C. It's the same thing. So it's 0.18 divided by the probability of C, which is 0.2. And so that gives us 0.9. And finally, the probability of the union between C and D. Well, the union is the probability of C plus the probability of D minus the intersection of C and D. So it is, let's have a look, 0.2 plus 0.6 minus 0.18. And that gives us 0.62. And that is section 4.7. You can use Venn diagrams to help. You can use sample space diagrams to help if appropriate. And you can also be rearranging the formulas.